All right. We're going to interlace some of the setup that should have been done before in with the talk, so please bear with me as we hit some of those bits because unfortunately I seem to be having some connectivity issues, but we can still kind of get you guys moving here. So this is Coding 1003. How many people went to Coding 1001 today? Handful. All right. How many people went to Coding 1002 today? All right, same group. All right, did you guys get something good out of it? All right, this is the next bit. All right, out of those people who did not raise their hands, how many people are familiar with REST APIs? All right, that's a good number. I asked that question 2 years ago and no one raised their hands, and then we were like, all right, this is going to be interesting. You guys, some level of Python knowledge, kind of up and down? All right, cool. All right, this is good. So this should be useful to everybody. My name is Matt DiNapoli. I am a developer advocate with Cisco DevNet in the DevNet zone. Are you guys having fun in here today? It's getting to be a little late. What's it, 5 o'clock? This is my third talk in a row. I need to remember to tell them not to book me 3 times in a row. I'm freaking tired. But, you know, we'll have fun. This one's relatively easy, so it's not too bad. If we can get our sandbox up and running, that would be great. What we're going to talk about is manipulating different types of file types. I know that doesn't sound super sexy, but it's actually kind of the basis for what we do with a lot of this stuff, right? The first area we're going to look at is XML. And the reason we look at XML is because that's the way the data comes back in our netconf protocol. And so we'll actually look, hopefully, if I can get everything up and running, at an example of being able to call into netconf and manipulate XML data with a tool called NC client. We'll then take a look at working with JSON and Python. JSON stands for JavaScript Object Notation, and we'll look at the nuances of that data structure in a minute. But that is going to be the predominant data structure for REST APIs. And so most of the interaction that you have with APIs over the course of the week, JSON will be the data structure that the data set is coming back in. So we'll spend a little bit of extra time on JSON, so you get a good feel for that when we're done. We'll then talk about YAML. YAML is nice for defining network devices. It's used across. Actually, YAML is part of the RESTconf protocol as well, the YAML and JSON type idea. But we'll look at raw YAML and how to manipulate that as well. And really, all of those 3 things are 3 different ways of structuring data. It's just a matter of, do we use squiggly brackets versus tags, or do we use a minus sign to delineate a new record, that kind of stuff. But I'm going to show you the tools that allows you to parse all of that into Python usable data structures so that it's really easy to actually pull out the data from that. So for manipulating all of these formats, we are going to use XML to dict, D-I-C-T, to manipulate our XML. What that does is it does a translation into what's called a Python dictionary. And a Python dictionary is a data structure within Python. It's one of the handful of Python data structures, and it allows you to map key value pairs. And that's really what's useful out of all of these things, is it ties to those dictionary structures that key value pair, okay? So that XML to dict is super useful. You're going to see a pattern as we go through this talk, as we do an introduction of the tool. We'll see manipulation of that particular data type, and then we'll hopefully be able to actually run a live call against a real device. The second one is JSON. That is actually a I can't remember the name of it. It's a standard library within Python, so you don't have to install that separately. So we can import JSON. We actually have another one called PyYAML, and that'll allow us to manipulate our YAML files. And finally, should you ever need to, and hopefully you don't, because it's a little bit of a pain in the butt, we can also show you how to manage CSV files if you have to do that. Ideally, we'll be all living in a world where everything comes back in JSON, but for the time being, we have a little bit of overlap, so we have to deal with potentially all of these data structures depending on the types of data that you're working with. Excuse me. So XML stands for Extensible Markup Language. It's been around for seemingly ever. It is a human-readable data structure that machines can use, or specifically applications written for machines can use. It is primarily delineated by tags, and so in our particular example here, we have a definition of an interface, we have a name tag to it, the description of that particular thing. It's very clear what we're representing here because of those tags. And so in this instance, we talk about those name value pairs. The tags in this instance are the name, right? And then in between those two tags is our value, all right? So kind of get that name value construct in your head because we're going to be seeing it a lot. It was originally designed for the internet. I don't know how old most of you are, but I remember people were talking about HTML, and that's the first thing that I dabbled in with computers when I was younger. And then XML came up, and then I thought I knew what I was talking about, but I didn't. So, but it was designed for the internet. It was designed to help transport data across HTTP, and it helps you define, or it's used by defining a schema or namespace for that particular XML file. For those of you who may have used in the past the SOAP protocol, you probably became very familiar with XML, almost nauseatingly familiar with XML at that point in time. It was one of the precursors to REST and JSON, and was one of the first ones I ever used. I'm not sure. I'm sure there were ones before it, but one of the more application software-driven protocols out there. And so that was the boon for XML. But as I mentioned before, we have that key value representation with the keys being our tags and our value being locked up in between. As we talked about, XML objects are surrounded by tags. They can contain other objects or data entries, and you can nest them within other objects. And so just like we do with code sometimes, anything under that interfaces object, we see it open up at the top there. We don't see a closed tag for it until we get to the bottom. So everything that's within that is defined within the scope of that interface definition, okay? And I know this seems all pretty simple, but understanding the scope of the data you're looking at is of primary concern. If I'm looking at this and I don't understand that this interface tag is a close, I might not actually fully understand what I'm talking about. Now, this is a relatively rudimentary example, but I could be looking at this and not necessarily understand what I'm looking at if I don't understand how scope works. So in this instance, our tags are open, and then they close off with that slash, okay? We can also do lists of things within items, and then each individual, say we have multiple IP addresses for a particular interface, we can list those addresses out. Each address, though, has to be encapsulated within that address tag, right? And then we can define our IP and net mask within that as well. Pretty straightforward, though, right? Any confusion? All right, let's actually get up into an example, and hopefully the world doesn't explode. I do want to try one thing. Sit tight. I'll talk through what I'm doing. So we're gonna jump into the sandbox right now, so I can spin up the sandbox, so I can actually show you guys live calls. This was supposed to be done before the talk started, but you could tell I was having some connectivity issues. Hopefully I'm not anymore. We'll just keep our fingers crossed on that. I'm going to reserve the iOS XE Catalyst 9000 Lab. This is actually a physical device, and hopefully it's reservable now. I was told we only had 2 of them. I thought we had a virtual iOS XE, but that did not seem to be available. So I can reserve this. For those of you who are not familiar, the DevNet Sandbox is a freely available, always-on tool for developers to reserve live Cisco equipment to write applications on. And so this particular device, I'm spinning up a Catalyst 9300, and within that we have, and then within that we have a dev box that I can actually go into and write applications against that Catalyst if I want to. But I can start playing with the APIs on real live devices in our sandbox, and it's all free. It's all part of DevNet, and so check that out. I think it's our most useful tool out there. I've been working for Cisco for, oh wow, it'll be 12 years in July. And I was part of the old Cisco Developer Network program, and our biggest problem was we were trying to get developers to come in and work on our stuff, and they were like, it's too expensive to set up our labs. It cost me $100,000, it'll cost me $10,000, whatever it was too expensive, which makes sense. And frankly, as a support engineer, that's how I came in. It was hard for me to procure equipment, set it up, rack it, and have it something to work against. And so as we started DevNet, one of the big things that we wanted to do was say, let's give developers easy access to our stuff. You know, if we want to build out our ecosystem, we want to build out our partner community, we want to build out developers that are able to do this stuff, let's set up a sandbox environment that allows them to do that with as little to no barriers to entry as possible. And then, once we got them hooked, then we sell them the equipment. Or have them build out an application that they sell to customers, which then sells our equipment. So there was, some downstream logic in that. But this is all available. It's going to take us about 8 minutes to get that spun up. That's okay. We have some local examples we can see. But I just wanted to plug a quick advertisement for the sandbox. And actually, now that I'm on it, while I'm advertising things, I did want to call out one more little bit that I think will be helpful for you guys, is learninglabs.cisco.com. The specific content that I'm going through here doesn't have a specific learning lab tied to it, but through a bunch of different actually, I take that back. There are learning labs that are tied to this. If we go to modules, I bet you we have network programmability in here. Let's see here. So for those of you who aren't familiar, and hopefully you will become very quickly, programmability. Maybe it's a track. Yeah, here we go. So there's a bunch of different modules. I think this one is tied more closely to what we're working on right now. But for other technologies, I cover, I'm the dev evangelist for Meraki and Cisco CMX, so I cover more of the wireless technologies usually. But we have learning labs for that and modules for that. We have modules and labs for this as well. And what they're designed as is self-paced tutorials to get you to walk through and learn the things that sometimes can be hard to pick up in a 45-minute session here, or you saw us do this and you're like, oh man, I really want to get started with that and really hone my skills. That's where you get started, is the learning labs. For the coding introductions, I think we do a pretty good job, but I would say that if you really want to become an application developer, some other tutorials are better. Ours are really designed for introductory to the language, understand that it's not too complicated to come across, and start to build out some simple scripts that might make your lives a little bit easier. And so I think we do a pretty good job with that. And this introduction to model-driven programmability ties pretty closely to what we're going to be talking about today. So, while killing that time with that little ad, let's waste no time and open up a little example for dealing with XML. So this is our XML file. We had already seen this in our slide, but now it's in real life in our code. And I want to work with that. There used to be a I'm totally missing where the code is. There used to be code that actually processed this. Let's see, we can kind of fly through that and make some changes. So Python part 2. Nope. There we go. Nope, those are the files. I apologize. All of this changed on me. All right. Well, maybe we'll just skip that and we'll go right for our sandbox environment. Is it ready to go? Still 4 minutes to go. All right, we'll skip ahead, and here's what we'll do. We'll go through all the data structures. I apologize for the way this is set up. Usually we'll go through a simple local instance, but it looks like the code has been removed on me. And I'll never again have 3 sessions in a row. So anyways, let's skip to JSON, and then we'll see examples when we get the sandbox up and running. So we have JavaScript object notation, similar to XML. It's a human readable data structure that applications use to store, transfer, and read data. So we're things that we're going to do over the internet. You notice a difference in the data structure in that the name value pair is tied closely together. Everything is delineated either by a curly brackets or square brackets. We also have colons, commas, and quotation marks in play. The definition of a name value pair, the left side is the name and the value is on the right side. So in our instance, when we're talking about name there, we have the name of the interface and the value gigabit Ethernet 2 as the value. Curly brackets define what we call an object. And so in this instance, we have an object called IETF interfaces : interface. So that's the actual name of the name of that particular object, and the value is everything in it. So that's the value of that particular name. And so we have our name, our description, enabled or not, the IPv4 address, and we see that that all can be nested. Now the other thing that I wanted to call out, and there's only one example of this, we could have multiple addresses on the IPv4 space, and we call out that array with those square brackets. So there's a big distinction between the object and the array. So curly brackets, if you remember nothing from this other than what I tell you right now, remember this. Curly brackets denote objects within JSON, square brackets denote arrays. So lists of the same thing. You can have, as you see here, an array of objects as well. So we have address definitions, and they're all denoted by the curly brackets, but they're scoped, and we talked about scope earlier, scoped by the square brackets here. So we only have one in this particular example, but we could have multiple. So that's what's indicating to me that that is an array. As you guys start to work with JSON, you'll start to notice these nuances within that, and it actually makes it a lot more readable. I know you can actually read the words and figure out what this is saying, but being able to understand how the data is actually structured is not just useful, it's necessary when you're writing application code, because if I want to pull out the IP address and print that on the screen, just a simple act of that, I need to understand that the JSON structure of the JSON structure of that definition, we have our IETF interface. I need to go through from that level. I need to understand that at that next level, I have the IETF IPv4, so I can skip name, description, enabled, but I need to get to here, and then I need to get down to address, and then within that, the IP address. So I have to understand how that data is structured to be able to actually code against it, right? So being able to read these kinds of files is absolutely useful. I already talked about all those things. So we have our JSON object, our JSON lists. And so in our example here, in our code, to be able to pull that stuff out, this is the code that should have been there, but it's not anymore. We have JSON_Python. And to get to that, if I just want to pull the interface name, that's at the top level. All I need to do is one line. Once I've transferred that into a Python dictionary, which happens up at the top, or actually right here, JSON.loads. It turns that into a dictionary, and then I can pull that name in. When we go through our examples, I'll get a little more into the code and how those things work, so you guys don't have to worry about that right now. But the functions for converting the JSON data into something that Python can read is JSON.loads, so then we pass in that JSON data. And then if we want to reserialize it, we can do that JSON.dumps and then pass in that data dictionary object. Sometimes it becomes necessary that when you read in data from a REST API and you're working with it, you always want to convert it into something Python can understand. Otherwise, you're going to not be able to do what you need to do. But when you're done with it, you might have to send that data back up. Maybe it's a configuration you're changing or something like that. And that's why you have to do that JSON.dumps, because over the data stream, it doesn't understand that you're sending it a Python dictionary object, and it'll yell at you. It'll say, hey, this isn't going to work. And then you'll run into problems. So understanding what those functions are super helpful. There's similar functions for XML as a matter of comparison. So I'm going back a little bit. The ones for XML, and they're not called out specifically in the slide, but turning XML into a JSON or a Python dictionary is absolutely necessary, just like it was for JSON, and that's done through a method called .parse. So that's from that XML dictionary library for XML files, and then for JSON, it's JSON.loads and JSON.dumps for JSON files. So again, that pattern, well, I shouldn't say again, this is the first time we've seen a repeat of the pattern. The pattern is get that data stream in, whether it's XML or JSON, convert it to a Python object using whatever the library's method is. For XML to dict, it was .parse. For JSON, it was .loads. Manipulate it as you see necessary for whatever your application is, and then reserialize it through, there is the XML one, I think is literally unparse, and for JSON, it's .dumps, okay? And again, we've done XML, we've done JSON, or we've talked about XML, we've talked about JSON, we haven't done anything with them yet. But we also have YAML, and YAML, I don't know if you guys know, this stands for yet another markup language. So they were pretty snarky about that. Although the argument is that it ain't a markup language. But just like JSON, just like XML, we use it to transfer data, store data, and move it along the internet. So it serves a similar purpose, and it's just a matter of how we're interfacing with our devices, if the data is going to come back in YAML, if it's going to come back in JSON, or come back in XML. You can see it's a pretty simple data structure, and it's defined by a little bit by indentation. It's also defined by these little dashes there. If you see a little dash, that is an indication of a list. Just like we saw the square brackets with JSON, I know that I could have multiple IP addresses as I read this particular file. Okay, so that's the similar nature of it. XML, in comparison, obviously it's very clear that you can have multiple multiple things in a particular list. If you can see that as it's set up there, but specifically the data structures of JSON and YAML indicate very specifically that you can put lists in. So again, JSON, those square brackets; in YAML, it's with that dash. Okay. I talk about all these things as they go. YAML list, so we just talked about that. So the notion of deserializing and reserializing YAML comes from YAML.load and YAML.dump, and they do basically the exact same thing that JSON.loads and JSON.dumps does when working with that particular file structure. The library that you have to install is PyYAML, and so it is not a native library like JSON is. So similar to XML.dict, you do have to install that. But just like that, we see that we do a YAML.load, and then we can manipulate that just like we manipulate our other Python dictionaries after we've converted it. So we do our YAML.load into a Python dictionary, and then we're able to pull out the specific interface name very easily, because now it's a Python data structure that it can understand relatively easily. So we don't have to go through, the thing that we're saving us from doing is most data sets that we end up looking at aren't short little definitions. There are ways we can start to filter out some of our calls and understand what we're working with in a minimal way. But for the most part, we're going to be working with large structures of data, and trying to sift out that stuff can be a pain, and you don't want to do string queries, which is basically looking, and that's all really JSON is a long string that has a bunch of curly brackets in it to delineate where the lines are. When you see raw JSON, it is tough to read, and you don't want to have to go through the process of trying to identify substrings as part of that. So being able to turn that into a easy to manipulate data structure like a Python dictionary allows us to do these things and say, if you see this, pull out the attribute name for me. And then I don't have to worry about looping through the string or doing any of that string manipulation stuff, which can be really, really difficult. So being able to convert these things to those data structures is absolutely key. We do talk about CSV just for fun. I have not come across an instance where I've been using an API and I've had to actually work with CSV files, but you could run into situations where you have data or you have something that you need to do where CSV could come into play. Unfortunately, you do have to do some kind of string manipulation in this instance. There are no fun loads and dumps libraries or methods that are part of that. And so in this instance, we're actually running a for loop that's going to pull out our code for, or not pull out our code, pull out specific information from that CSV file. So the CSV file in question had 3 columns. It had the name of the router, what city it's in, and its IP address, all comma delineated. And so being able to pull that information out specifically for those, and you can see what the data looks like up there, requires us to write a for loop to then loop through each row. And now I have to do things a little more manually in my code, which I guess sounds a little paradoxical, but even so, it's a lot harder to work with than those Python objects that we're turning all those other data structures into. Okay, cool. Hopefully our what time is it? All right. Oh, HTTP calls. Okay. So the other thing that we talk about, that was weird, are HTTP calls. We used a library called requests to do that. It does all of the heavy lifting for us. As far as making REST API calls, since REST API is based over HTTP, we're going to make those calls, and now we don't have to worry about setting up the connection. We don't have to worry about the data stream. We don't have to worry about, hey, how do I pass all this stuff in? That requests library does it all for us in Python. You guys are going to see that in almost every bit of sample code that you come across from DevNet, because we are making HTTP request calls to those services. So that's another library to become interested in. If you're working with Yang model data from netconf, and this is where we get into those examples, and we'll actually see these very directly. We're going to use XML to dict because XML comes back over that netconf interface, as I mentioned earlier, and it handles all the details. NC client handles all the details of our connection to our actual device, so authenticating our service, any remote procedure calls we're going to do, and any operations we're going to push through to that service. But it does deal in raw XML, which is why we talk about XML at the beginning of the course here. And I should note, I failed to mention, when we talk about HTTP requests, taking one step back here, we are doing this over the RESTconf protocol. So you may be more familiar with RESTconf now than you may have been about a year ago. It is now a ratified standard. I believe all of our new devices or all of our updated firmware support it. I don't know that. I don't know for sure where the cutoff is, but the documentation for that particular firmware will let you know if RESTconf is in play. But these are all different ways of getting to the same data. RESTconf, netconf, getting to the same data or manipulating configurations. And then we have CLI access, and sometimes this is the only thing left to you. It's becoming less and less, well, ideally, it's becoming less and less available, or necessary, I should say, to go through this path. But there are Python libraries for that as well. The one that we talk about is NetMiko, and this is actually a pretty popular and relatively well-used library across the industry. If you want to learn more about Paramiko and NetMiko, I'm sure there are dozens of tutorials that tie exactly into what you would need to do with those. But it does the same thing that the HTTP that request does, that NC client does. It handles our connection. It's an SSH connection in this instance, but it handles our connection. It allows us functions to send our commands, and so it gives us that opportunity to do that as well. So 3 different ways we can interact with our devices. RESTconf, if it's available, netconf, which is probably available, and if all else fails, we can hit it up with SSH through NetMiko. Okay, so let's see. Before we get into error handling and logging, let's see if we can get into our sandbox environment. So I should have gotten an email in here that says, hey, your sandbox is ready. And then we can connect to that. So bear with me 1 second. Don't run away. Maybe I can answer some questions if there are any questions. Nope. Okay. Let's see here. Still downloading. Sandbox Lab is ready. Alrighty. Literally everything is so slow. Come on. So while I go through this, so for the reservable DevNet sandbox environments, we set up VPN credentials so that you have a self-contained lab. So this got spun up, which is why we had to wait a little bit of time. And then I can manipulate this environment however I want. I can destroy it. I can make all kinds of changes, blah, blah, blah. And then what happens at the end of my reservation, we have automated processes that tear them all down, and then they sit dormant until someone else requests the service. And so we're going to hit up DevNet Sandbox, sj.cisco.com, 20345. So you're issued your own credentials as well for that particular reservation. So those don't carry over to any other reservation. So they only exist as long as the reservation exists. And within these, they give me information about how I can actually get to the device. And so for this one, our username and password is admin and Cisco SBTD. My different ports for my 3 different ways that I want to connect are set up here. And so I need to make some code changes based on that. And so what we'll do, so I'm connected to the sandbox. We're going to run a NC client example. So that's the one that's going to walk us through connecting through netconf and requesting some XML data. So bear with me one second. And we will pop this open. NC client example. And okay, so we want to connect to 10.10.2100, and our port for netconf in this instance is 830. And the password was, I kept typing it in wrong the other day, and I was like, why isn't this connecting? Cisco PSTD. And I do know that I need to change this to 1/0/1. All right. So I kind of glossed over the code before, and the reason is because I usually don't teach from the slides because everything's usually working. But the first thing that we're doing, I've installed NC Client as part of my service, or as part of my application. I'm importing NC Client, and more specifically, I'm importing the manager method as part of that, and that's going to manage my connection. So that's that first line where it says from NC Client import manager that we're going to do. And then that's going to manage the connection to the device through that 10.10.20.100 through port 830, and it's going to send my credentials, and then when I get my XML back, I'll get that XML, I'll use that XML to dict to parse that data. Now, I am setting a netconf filter. This is actually a live switch, and it has dozens of interfaces on it for obvious reasons. And so I'm going to filter just based on the first one. I believe I have that filter set up right. The way things have been going, I wouldn't put it past me that I didn't. But if everything works out properly, we're going to call this git config for our from our NC client manager. It'll get our running config so we can get those devices, and then coming back, we'll parse that with the XML to dict.parse, and that will do our job of actually taking the XML that has come back, turning it into a Python object, so that all I need to do to parse out data, which is ultimately what we all end up doing with any of this stuff, is to put in one line of code that ties into how the data is structured. So fingers crossed that maybe something will work today for me, and we'll get this going. All right, this is in the NetProg Basics section. And we're in Programming Fundamentals. Python Part 3. One quick Python note. This little gray, the white are files and the gray are directories. That directory that I have right there, Python Part 3, is called a virtual environment. And so I'm going to enable that virtual environment. And for those of you who attended 102 earlier, I hope they told you what virtual environments are. If they did not, shame on them. But what we are setting up here is a self-contained Python environment. Python Part 3. Hold on. Yep, that should work. Oh, it's not active. It's hold on one sec. Put in the wrong command. Activate. All right, so now what I've done, my command line changed a little bit, and it put this little parentheses thing around it. And what that's telling me is I now have a self-contained Python environment with which to work from. The challenge with Python sometimes is that you can have multiple installations of it. You can have libraries stepping on each other here and there. And so whenever you're working on a project, I cannot stress this enough. Please work from a virtual environment, because you can get a lot of false returns because one library is stepping on another, or you're not running the right version, or blah, 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 blah. And this is a way to make sure that your projects are working properly in a contained environment. And so I can take a look at the packages that are already installed using a command called pip freeze, and I know specifically that these are tied to the exact code that I'm going to be running in the next 4 minutes. So for instance, NC client here, that's the one we're going to be hitting, okay? And so I know if I deactivated that, we'd see a whole list of libraries that I don't even know how they'll interact with some of these other instances, right? So always use virtual environments is the key to that one. Alrighty. So now let's run our NC client example. So Python API NCI client example.py, and barring any mistakes, we should see some success. None type, non-subscriptable. That means that we did not get anything back, or not that we didn't get anything back. The filter was wrong. So what we can do is let's turn the filter off, and we'll just print all of the data. We'll take away the filter. Now we will get an error on this code, but at least we'll be able to interface netconf.xml. Print. Should just print everything. This is what actual coding is like, people. Let's see if this works. Come on. No. Would help if I typed properly. TP ring. It's not a thing. What pprint does, if you're wondering, is it formats that stuff into a little bit easier to read format if we get any data back. Which, there we go. What is this? Yeah, so this is all of the interfaces. And you can see it would be helpful if we could apply that filter. And so let me make sure that gigabit Ethernet 1 is even in here. All right, let's just do 10. We'll try that. And then we'll move on if we can't get it successful. But I at least I got you guys through the gist of what was going on there. Yeah, it's not finding that properly, so I apologize. What's that? Oh, was it 10? Oh, the word 10 in front? Did I miss that? Thanks. It's hard to troubleshoot code in front of 100 people. Does that work? Hey, good call. All right, I missed the word 10. So my filter was inappropriately set. So we were looking at the 10 gigabit interface, and now we're able to pull that specific one out. And if we wanted to, now we can work with it. And this line just printed out the result set, but this line here is actually parsing out the name specifically for us, because it matches the structure. And thank you for that. It matches the structure of interface name and then star text. So we can match that up and actually look at the result and say, where is it? Interfaces, interface, name, and pull the text out there. So thank you I appreciate that help. You get a gold star. We also have the API requests example. Now RESTconf is on a different port, so I'm gonna have to change where we talk to that there. And once we get that done, I'll let you guys go. Are you kidding me? 10.10.20.100, right? I don't remember what the username was. Admin. The password was Cisco PSTD. The port's usually 443, but I feel like it wasn't specifically for this one. We also need to make the change for this particular device. Now for RESTconf, the data is going to come back in JSON. And so we were going to want to manipulate that JSON as part of this. We are going to import requests at the top there so that we can make our call. So instead of NC client, we're using requests to manage our connection and grab our data. We definitely don't want that. So we want 10 gig Ethernet, and we have to escape that. %2F. %2F. And we're going to print out that JSON. We're going to create a JSON object and send that into API data. And then based on the interface definition, we can then grab the name out of that. So I just want to make sure I double check the interface because I don't want to send this to 443 if 443 is not the port. And oh, it is. Okay, so we could have run it. So we're saved here. And ideally, we should have a similar result, but it's just a different method. Python API. All right, sweet. So a little bit more information out of this one. Actually, that should be probably the same information, just formatted a little differently. Because we PP printed it, or P printed it, it put it into a nice readable format for us. And we see that we parse out from our interface object, and having the hard returns in there makes it a little bit harder to read. But we have our interface object, and then 10 gigabit Ethernet, and then we're able to parse out that, or we should have been able to parse out that at the bottom. We didn't print it out. Let's run this one more time, and then we'll call it a day. And if you have any questions, I will gladly answer them at the end. So 1 second here. There we go. Now we're able to pull out our name at the bottom. Everything seemed to have finally worked, so that's good. At least you guys got to see some real live examples. Thank you for hanging in there. I hope you learned something, and I apologize for some of the, I don't want to say I wasn't prepared, but it seemed like I wasn't prepared. So I apologize for being seemingly not prepared. So if there are any questions, you can meet me on the side here. Head over to the Start Now zone. All of this code's available through our Cisco Code Exchange, where we have all of our, or DevNet Code Exchange, where we have all of our sample codes, anything that supports a learning lab. Use the sandbox if you'd like. We really enjoy people using that. The more that people use it, the more we have justification to spend more money on it and to make it better. Enjoy the rest of your time in the DevNet zone, and have a good evening. Cheers.